Hey everyone, welcome to the Polymath Developer Town Hall on this beautiful Friday. I just want to introduce myself before we get started. My name is Charles St. Louis. I am Polymath's new open source developer community manager. I just started a couple weeks ago, but really excited to leading these town halls. Alongside me, I have Satyam and Adam, as you can see, who I'm sure you've seen their faces before. Unfortunately, today we couldn't have Paolo join us, our VP of engineering. He had a baby, so I guess he gets that excuse. Anyway, today on our agenda we have our Polymath Core Toro version 1.10 release, and with respect to that, we have the introduction of our bug bounty program for external developers. So without further ado, Satyam is going to go ahead and talk about the Polymath Core version 1.10 and all the features that come with it.
Thanks, Charlie. Hello, folks. So we all know that we just published our 1.1.0 Toro release that is majorly focused for the issuers, that the new features we added. So I'm going to do a walkthrough with the latest features that we added in the latest release. So we are using the Solidity 0.4.23 compiler version to facilitate the revert and to facilitate the reason strings for the revert and require statements. We are following the modular architecture for the SC20 tokens. So for that, issuer can add multiple modules for whatever the functionality they want. In respect to this, we added count transfer manager and percentage transfer manager that will work. So for the count transfer manager is work to limit the number of the token holders. If I am the issuer and I want that I want only 1,000 token holders, so I can limit those token holders using the count transfer managers. Same as a percentage transfer manager that will restrict the holder to hold a certain percentage amount of tokens with respect to the total supply. So it is basically used for complying the bad actors rule. So it's a very good feature to use. We also add the pausing feature in the security token as well as on the level of the modules STOs. So this feature can be used by the issuer at the time of big announcements that they want to do, or if there is any hack over the exchange and they want to restrict the transfers. So this feature can be used in an ad hoc manner, and we also following the real scenario of the shares. For that, we make our SC20 tokens indivisible by default, as we all know that Vitalik also suggests that we have to use the 18 decimals. So we are following that rule, and issuer can have the feature, so they can add or they can have a flexibility that they want indivisible token or the divisible token. But in both features, the token have the 18 decimals. We also have the taggable features for the modules, in which if I am the issuer and I want to sort it down the list of STOs that have a feature of pause feature, or they have the cap, so I can search or filter them through these tag in the modules. So this is very extensively used in the DApp level, and we also supporting the burning feature. So in that feature, that's a totally pluggable feature. If the issuer wants to use that feature, then they can plug the token burner contract, and on the back end they use the mechanics for the burn function. The reason of you using that function, the burn, is that if the issuer wants to eliminate certain types of shares, or want to issue the tokens again, so eventually they want to burn the all existing tokens. Following that, we also added the KYC expiry time in the for the whitelist for the whitelisting of investors. So if I am the investor and I change my location and my wealth is increased, so it's actually affect my KYC level. So some of the rules and regulations governed by some of the authorities that at a particular time level the KYC should be redone for the investors. So we are also following that rule, and by following the Philippe article about the off-chain whitelisting, we are using that feature in our Polymath core that will save the money of the issuer by sending some piece of signed data and help the investor to whitelist them for the STOs. We are live with our all contracts for the latest release on the Core 1, and because of the gas issues, we did not publish our contracts over the Ropsten. That's we all know that Ropsten have 4.7 million gas limit, but we are reaching the 5 million gas limit, so we are using the Core 1. So please stay updated with the latest releases, and it will in future it will come up with more features. So Adam have a list of buckets. Sorry, a bucket with have a new with the list of new features in the next release. So Adam, over to you.
Thanks, thanks, Satyam. So yeah, so I think one thing I guess that's worth kind of mentioning, which I think applies to the things that Satyam just said and the features I'm about to talk about, is that one of the things that's been quite nice is that because we have this kind of modular approach to functionality, adding new functionalities is pretty easy, right? So so Satyam mentioned some new transfer managers for kind of restricting transfers based on the number of investors and what percentage of tokens they hold. Adding that type of functionality is super easy because it's just they're totally kind of independent modules. They can be audited independently and they can be kind of added and removed to existing security tokens or obviously new security tokens. So that's been kind of one thing that's been nice to see for the last release and for this release, is that is that kind of that architecture making our life easier and the life of issuers and people using the protocol easier. So I'm going to talk about, so we're at the moment, so we released 1.1.0 last week. I think it was last week. I'm going to just talk about some of the features we're working on for the next version, which is 1.2.0. So there's a whole bunch of features. So I'm just going to pick out a few of the kind of more interesting ones or the larger ones. So one of the first things, one of the bigger features we're adding, so when we talk to issuers, one of the kind of common requirements they've had is they want to be able to pay dividends and perform governance, so things like votes on chain. So as part of, so based on based on their token holders and the balances of those token holders, they want to do voting or governance and dividend payments, which are two types of events that also obviously happen on with traditional securities. So with the kind of standard ERC20 or with the standard ERC20 token, that can be kind of tricky, and the kind of user experience can be quite painful. There are various ways you can do it. You can stake your tokens for a smart contract and vote based on that, and then there are kind of various other implementations. So the approach we've taken, we think, is pretty flexible. So we've introduced a new module type, which is we're calling checkpoint, and what that allows you to do is it allows you to build a module. So for example, a dividend module, and when you pay a dividend, so when say the issuer wants to pay a dividend of say 1,000 ether or something, the dividend module tells the security token to create a new checkpoint. And what that means is it means the dividend token the dividend contract rather can query balances as of that checkpoint. So if if the issuer pays 1,000 ether dividend as of the 1st of June 2018, it means that people can claim their portion of that dividend based on their balances on the 1st of June 2018 rather than their current balances, which avoids lots of the kind of double claim problems in dividends, and similarly for voting, kind of double vote sort of problems which you have with ERC20. So it's kind of a work in progress. We've just kind of just finished the main PR today, which if you're interested, you can go and check out on GitHub. It's still being reviewed at the moment, so it's not been merged into master. If anyone has any comments, we're super interested to hear those. So that's one big change. Another change we added. So we added the ability for transfer managers to differentiate between calls to verify transfer. So we allow transfer managers to differentiate between the case where people just want to check whether a transfer is valid or not, and the case where people are actually executing a transfer. This is kind of useful. It means that transfer managers can maintain state based on transfers that occur. So, one example where this kind of use case where this would be useful is if, let's say, transfer managers wanted to maintain a count of how many token holders there were. In that case, they need to know when they're being called as part of an actual transfer versus being called just to kind of check that a transfer is valid, but in a kind of more speculative way without the transfer actually occurring. So we added that. We've added another transfer manager, which we're calling the manual approval transfer manager, which lets issuers manually approve or manually block specific transfers. So, specific transfer between, say, Alice and Bob can be blocked, or a specific transfer from Bob to Alice can be approved, say, to a maximum of 100 tokens. In both cases, there are expiry times, so the issuer can kind of create that approval and stick an expiry time after which the approval is no longer valid. So that's the transfer manager. One thing, so Polymath talks lots of kind of third-party organizations in the ecosystem, so people like KYC kind of providers and exchanges and wallet providers and custodial services and that type of thing. And we're working with a whole bunch of different partners who are building modules for the Polymath protocol. One of the kind of requests we've had from those types of organizations is they would like a more flexible way of levying fees from the issuer for their modules. So, for example, if you're a KYC provider and you want to build a module for the Polymath ecosystem, at the moment, there are two ways you can charge for that. One is a upfront kind of one-off fee, which the issuer pays to attach the module to their token. And the second way is a kind of what we call per action fees. So in the KYC case, maybe every time an investor is KYC'd, the issuer would pay, say, 100 poly. So some of these third parties have also asked for a new kind of fee structure, which is a sort of subscription fee. So where the issuer would pay, for example, 1,000 poly per month, or 100 poly per week, or something like that. So kind of time-based subscription fee structure. So that's something we're working on in 1.2.0 as well. And then the last one, which is still very much a work in progress, and we're sort of discussing at the moment, is so in the traditional securities markets, you have transfer agents who kind of act on behalf of the issuer to help security holders transfer, buy or sell their securities, and kind of make sure that those purchases or sales, are kind of conform to the right regulations. So we're looking at how to kind of introduce that concept of a transfer agent into the Polymath protocol, so a kind of actor or an entity that the issuer can delegate some control over transfers to, and that's off the back of some conversations we've been having with kind of transfer agents in the traditional securities market who are interested in, are very interested in kind of tokenized securities and what their role would be in tokenized securities. So those are some of the kind of the headline features. There's a whole bunch of smaller bits and pieces we're putting in as well, but those are some of the more kind of interesting, at least to us, features we're putting into 1.2.0.
That's awesome. Just for all the attendees, feel free to ask any questions in the question box, and we'll answer them as quick as we can. If not, reach out to us on our GitHub or anything that works that way off our Medium accounts as well. So just to wrap up the final thoughts on the Polymath core release and the future kind of features that are coming out, we're one step closer to get a framework that we feel confident applies to issues with regard to functionality requirements as well as regulatory compliance. So with that being said, with the most recent release, we are extremely to announce the Polymath Developer Bug Bounty Program, which was posted this week and last week on our Medium account and on our GitHub. So I'm just going to kind of introduce what that's all about to you guys so you can kind of hop in, try to fix some bugs, and make some money. So the Bug Bounty Program is released for all our external developers to kind of go in, check out the bugs before our formal audits. So we're kind of giving the community the chance to learn their developments, apply their expertise, and make some money from it. We're really working on getting all you guys involved with this because it's going to be the standard platform. So we want all these external developers to kind of hop on and help us together. And who knows, it might even turn into some great job opportunities. So with that being said, I wanted to kind of get into the details. So we have a huge list of kind of potential audits that we're going to go into, and Satyam and Adam are going to mention some of the brief contracts that you guys can dig into. But I just wanted to say that these bugs range from in criticality. So there's a bunch of bugs that are going to be low and high. So with respect to the lower ones, the reward will range between 1 ETH to 8 ETH in terms of the highest criticality ones. But participants have the opportunity to choose if they want poly tokens instead or not. So Satyam and Adam, I'd love for you guys to talk a bit about some of our bugs that we want you guys to find.
Yeah. So I guess just to kind of to preface it and try to encourage people to take a look. So the bug bounty's been running officially for a few days, and internally we've definitely found quite a few examples of bugs that would have been, unfortunately, because we work for Polymath, we can't claim the bounties, but would have been eligible for bounties if you guys had found them. So there definitely are bugs out there, and I say that as one of the developers who wrote the code. But there definitely are bugs out there, and the rewards are pretty substantial for this type of bug bounty. And one other thing to mention, so we're taking maybe a slightly less usual approach, which is we're opening up the code for a public bug bounty ahead of our formal code audits. So we have obviously a whole bunch of, before we obviously release this version onto mainnet, we'll go through formal code audits with Solidity experts or organizations. But usually organizations will do the formal audit first and then the public bug bounty afterwards. We're kind of switching the order to try to give the kind of developer community a really kind of good opportunity, quite ripe pickings in terms of bug bounties before we take it to the formal audit. So if you're going to get involved, now's a great time. You probably have a couple of weeks before we start those kind of formal audits. So it's a great time to kind of look at the code and try and find bugs, because I can almost guarantee there are bugs out there. So something we found certain a few eligible bugs already. So if you're a Solidity developer and you fancy earning some or claiming some kind of ETH bounties, it's a great time to get involved. And also, as well as bugs, we're super interested in any feedback, and if you have kind of useful or comprehensive feedback, we'll definitely look at that. And we're obviously always interested in kind of growing the kind of Polymath network and family in lots of different ways. So in terms of the contracts themselves, so we have so there's a Medium article which is on the Polymath blog, which has lots of the kind of low-level detail and lists out all the contracts that are in scope and so on. There's a few kind of key contracts. There's probably in some ways the most important contract, which is security token.sol, which holds the kind of base security token logic. So that's one of the key contracts. And is a good starting point, especially if you're maybe don't have a huge amount of experience, because it's the code is relatively comprehensible, and all the code should be well commented as well, following the kind of NatSpec code commentary style. So that's one key contract to take a look at. The general transfer manager is another good contract to have a look at. And I think both in the General Transfer Manager and the Security Token contract, we found bugs, so they're good contracts to take a look at. General Transfer Manager contract is the one that kind of has this sort of lets issuers set up these rules to restrict transfers in a broad sense. So that's another great contract to look at. And then there's there's lots of other kind of modules. The modules are quite nice because you can kind of look at them in isolation as individual contracts and not worry too much about the rest of the protocol. So if you want somewhere kind of quite easy to or accessible to start, the modules are a good place to do that. So those are some of the key contracts, and we have if you have any kind of questions either about bugs or about the the kind of code or the behavior or anything like that, we have a Gitter channel which is Polymath, which is linked to our GitHub, which is gitter.com/Polymath network, and our developers hang out on that. So if you have any questions and want to kind of find out more about the code, you can jump on there, and we're happy to answer any questions, or you can enter issues on the GitHub as well. And we're kind of keen to hear about bugs, and we're also keen to hear about just general commentary about the architecture or the functionality or anything else really. So those are some of the contracts. And the other thing I guess it's worth saying is that it's also possible to write, if you have a good idea for a new sort of security token functionality that could be wrapped up as a module, that's another kind of great way to monetize your knowledge, because as we kind of referenced earlier on in the talk, you can create modules and charge issuers to use those modules. So if you create a module that lots of issuers use, and you can obviously charge whatever you think is a fair amount for that, then that's another kind of great way to get involved in the Polymath protocol as a developer. So those are some of the key contracts. Yeah.
Satyam, did you want to add anything, or did Adam cover it all?
Actually, Adam covered it all. I'm just want to add this that this bug bounty program is a continuous level. So if we are going to release the next versions, then we have a next bounty level. So you can participate over the multiple levels. So at the brief understanding that Adam said that we have a starting out entry point is called security token.sol, security token registry, and the general transfer manager. So go through those contracts. If you have any doubts related to any of the functionalities, you go over our social channels, our Gitter channel, where we are try to build our developer base. So you can communicate with directly with the core developers over there. So and also if you want that some of the functionalities that will be related to the shares, or I can say the equity or the securities, and you want to add those functionality in the Polymath core protocol, so you can give us a proper feedback, so we can try to implement, or you can implement by yourself, as Adam says, that you can earn money through that. So it's a nice way to get money, to be a part of the Polymath, and also be a part of the revolution that we are trying to build for over the blockchain. So it's a nice way to interact.
Well put. So before we wrap this up, I just kind of wanted to go into the submission process if you find a bug. So essentially, you would just go in and create a new separate GitHub issue on the Polymath core repository. Your submission would include the following details, such as a description of the location and the potential impact of the vulnerability you found, your observed behavior, expected behavior, and essentially then you'd input how to replicate. So a description of the steps required to reproduce this vulnerability that you found, your POC scripts, steps taken, you can take screenshots, however you feel most comfortable. And then we'll probably respond within 96 hours to verify that the bug you found was legitimate and that your solution is sufficient. Then the payouts on the bugs will be sent out to an ETH address or however we wish to proceed. But with that being said, that wraps up our developer town hall for this Friday. I want to thank you, Satyam and Adam, for joining me. I'm looking forward to the next one in a few weeks' time. Thank you, guys.
Thank you.
Thanks,
Cheers.
Ali.